Hi everyone, I'm Mr. Fullerton, and I'd like to talk for a few minutes about electrical circuits. We're going to identify the path and direction of current flow in a circuit, both conventional current and electron current, and we're going to draw and interpret schematic diagrams of circuits. Those are our goals for today, to understand conventional current flow, electron current flow, and how you can use a circuit schematic. So, a circuit is a closed-loop path through which current can flow. If it's an open path, no current flows. Conventional current, what we call positive current, flows from high potential to low potential through a closed loop, which means that electron current flows in the opposite direction. The actual electrons flowing in a circuit go from low potential to high potential. Now again, if the path isn't a closed loop, no current will flow. If there's not a complete path around the circuit, nothing moves anywhere in the circuit. It's got to be closed for anything to move. One of the tools we're going to use to analyze and help understand circuits is called a circuit schematic. And it's a two-dimensional representation of a three-dimensional circuit that makes it a lot easier for us to see what's going on in the circuit. It's important to note that current flow requires a source of potential difference. If there's no potential difference, or if it's an open circuit, no current flow. But if you have a source of potential difference, something like a cell or a battery or a voltage source of some sort, then you can get current flow. So some of the circuit symbols we're going to use in schematics are things like a cell. You can see this here at the top. The longer line is always the positive side. The shorter line is the negative side. And I remember that by thinking the longer side takes more ink to print, and so does the positive sign. The shorter side uses less ink, therefore you use less ink for the negative sign. A battery is just a series of cells, a number of cells put together. So the symbol for it shows a couple of cells. And again, the long side is the positive side, the short side is the negative side. Below that we have a switch, which can be either opened or closed. If it's open, no current flows. If it's closed, then you can have current flow, assuming the rest of your circuit makes a closed path. A V with a circle around it is a voltmeter. That's a tool that's used for measuring the potential difference across a part of the circuit. Below that we have an ammeter. That's an A with a circle around it, and an ammeter measures the current flow through that portion of the circuit. Below that we have the zigzag symbol for a resistor. Looks kind of like Charlie Brown's shirt. And what that is, we've talked about resistors, something that impedes current flow. And a variable resistor below it just has the arrow pointing to it. And the idea with the variable resistor is it's a resistor where you can dial in the resistance you want. Finally, below that, we have the circuit schematic for a lamp, a couple of loop-de-loops inside a circle. And really, a lamp is basically a resistor that glows when you put current through it. So functionally, it works the same as a resistor in a circuit. The only difference is it gives off some light when it has current flowing through it. So let's see how we can apply some of this. Current only flows in a closed path. So on the left-hand side, you see an open circuit. We have a switch, but it's not closed. You can't go all the way around the loop. You can't go from positive potential all the way around to negative. Therefore, no current flows anywhere in the circuit. You have to have a closed circuit, like is shown on the right, to have current go all the way around the path. And because we have current flowing through the entire path, we see that the lamp on the right is lighting up. It has current flowing through it, the lamp is turned on. It's a sample problem. Show the direction of conventional current flow and electron flow in the schematic. Well, as you recall, conventional current flows from positive or high potential to lower potential. So we're going to go from the higher side of our voltage source to the lower side. So conventional current will flow in this direction. There's our conventional current. Electron current, as you recall, goes in the opposite direction. Therefore, electron current is potential to the higher potential. So there's the direction of our electron current in red. Now there's much more to circuits and a bunch more schematic symbols, and you can spend years and years getting into deeper and more complex circuits. But this should get us started, and we'll follow up with some work on series and parallel circuits in the very near future. If you have questions, need more help, want to go into more depth, check out aplusphysics.com. Thanks for your time and make it a great day.